Hello, my name is Bruce Odekirk. Today in this presentation I'm going to cover the two projects that Microchip has with Power America. The first one is Task 220, productization of 3.3 kV and 700 volt silicon carbide MOSFETs. And the second project is Task 2.3, silicon carbide production in a high volume, low cost 150 millimeter fab. The project objectives for Task 2.2 were twofold. First was to design and commercialize 700 volt silicon carbide MOSFETs to compete with and displace silicon superjunction devices. And the second was to productize 3.3 kV class of silicon carbide MOSFETs to compete with 3.3 kV IGBTs. The project objectives for Task 2.3 were primarily to establish a high-volume, low-cost silicon carbide device manufacturing capability in our internal 6-inch CMOS fab. This fab is located in Colorado Springs, circled here. It's a 6-inch fab that's been there for a while. It's got on a 50-acre site, 310,000 square feet of clean room, 10,000 wafer a week CMOS type capacity, 250 nanometer technology capable, and all of the appropriate certifications required for this product line. Now I'd like to briefly go over the technical progress we've made on these two projects, starting with the device project, Task 2.2. We've completed fabrication, test, and data analysis of a lead 700 volt MOSFET design matrix with multiple process and implant splits. We achieved the goal of 30% reduction on specific on resistance for 700 volt MOSFET. We've selected a design version from the design matrix that was most suitable for the commercial design. Mass making for that is now underway. We've also completed and narrowed down the process and epi material splits for the lead lot of the commercial design, and that will include splits on epi specifications. For the 3.3 kV MOSFET, we've completed a lot of builds and data collection and analysis for various types of various sizes of MOSFET, and those are now entering commercial qualification stage. All lots, as I said, have been completed and tested. Qualification testing material is either in assembly or now post-assembly. Datasheet preparation is underway. We have some preliminary data sheets. And we also have some limited customer sampling underway. Moving on to the technical progress on Task 2.3, which is the wafer fab project. We have completed acquisition and installation and modification of initial toolkit for silicon carbide manufacture. We've completed the silicon carbide process module development, verification, and routes have been placed for Schottky diodes and MOSFETs. We have also completed design and fabrication of 700 volt, 1200 volt, and 1700 volt Schottky diodes, ranging in sizes from 10 amp to 50 amp at all three voltage nodes. And we are expecting product qualification for this, for the Schottky diode family, around Q4 of this year. For the MOSFETs, we have completed and verified the gate oxidation process setup. We've achieved the interstate trap density that we were targeting, and we have completed designs for 40 milliohm 1200 volt and 35 milliohm 700 volt. And those lead lots for each of those are in the line and expected out in middle of August. I'd like now to discuss the expected outcomes from these two projects. We believe that the dual manufacturing sources will provide much better flexibility and significantly reduce risk for volume production demands. Since we're already in production with XFAB, getting the internal production qualified will suit that purpose. We also firmly believe commercialization of cost-competitive 700-volt MOSFET will open up significant markets, thereby allowing us to increase the volume of silicon carbide power devices. Also, the addition of 3.3 kV devices to our product portfolios will broaden the application space and really leverages the best features of silicon carbide. We also believe that Microchip's superior business features will be utilized to drive larger volume sales of silicon carbide devices. Some of these features that Microchip brings to this are their extensive worldwide marketing, sales, and distribution network, their significant involvement in automotive, medical, and defense sectors, their ability to rapidly develop customer involvement in high power traction, transmission, and distribution, and our ability to leverage the power module group in Bruges, France. Thank you very much for your attention.